Hello everyone, I'm Dr. Godan Raman. In this section, we are going to discuss with the problem of one-dimensional wave equation with non-zero initial velocity and zero initial displacement type of problem. See the problem, a tightly stitched string length L with fixed ends is initially in equilibrium position. It is set vibrating by giving each point velocity V0 sin q pi x by L. Find the displacement y of x comma t at any time. Now when I'm looking the problem is mentioned string. So when the problem is mentioned the string, we know that the string stitched one endpoint to another endpoint. When I'm giving the force, it vibrate. So the wave is created. Therefore, the problem is one-dimensional wave equation. Okay, once you identify the given problem one-dimensional wave equation, then you check the problem is initial velocity 0 or non-zero. Now this problem, look at here, velocity value given. When the velocity value given, then is non-zero velocity. So this is a type 2 problem. Now you just write the one-dimensional wave equation, then this is the suitable solution because of we have possible 3 solution, but the suitable solution is this is our suitable solution y of x comma t a cos lambda x plus b sin lambda x c cos lambda a t and d sin lambda a t. So first boundary condition, the one end x is 0, therefore y of 0 comma t 0 because no displacement of this endpoint, and then x is 0, t greater than or equal to 0. Then second condition, second boundary condition, the second end is a length L, L comma t 0, then x equal to L, t greater than or equal to 0. Then the initial condition. So previous type, when the initial condition velocity 0, then we are writing in the third condition. Initial condition, third places we are written in the third condition. Now velocity values are given. Velocity is the function. Therefore, displacement only 0. Y of x comma 0 equal to 0. No displacement. T equal to 0. X is nothing but 0 to L. And then the fourth condition, initial non-zero initial velocity. Therefore, though y of x comma 0 by though t equal to V0 sin q pi x by L. So this is a given. This is our initial velocity. 0 is nothing but x is nothing but 0 to L. Here y of x comma 0 0 because of the reason no initial displacement. So only the reason t 0, then the values are 0. Then the 4 condition is here, using first condition to find the constant, because constant a b c d, we should find the constant value based on the using this condition. First, using condition 1 in equation 1, what is the first condition? Put x 0. So in the first condition, when I substitute x 0, y of 0 comma t, then a cos 0, b sin 0, then c cos lambda a t plus d sin lambda a t. The left hand side value 0 because the boundary condition 0, a c cos lambda a t, d sin lambda a t. Now this whole terms are non-zero, therefore take it in left hand side. A is 0, a equal to 0. Now I consider this is a second equation. Substitute second equation in the previous equation 1. Therefore y of x comma t equal to b sin lambda x, c cos lambda a t, d sin lambda a t. Now you consider this is equation number 3. Now first condition I am using a0. Then second condition I am going to apply with this previous equation, third equation, using condition 2 in equation 3. So what is the condition? X equal to L. So substitute x equal to L in the third equation, y of L comma t, b sin lambda L. then cos lambda at d sin lambda at. Now this left hand side, the boundary condition 0, b sin lambda L, c cos lambda at, d sin lambda at. Now this term non-zero, this term non-zero because of when I'm taking b0, already a0, b0, it's a meaning when I substitute previous equation all values are 0. So no solution because it's a trivial solution. Therefore b non-zero, 0 equal to sin lambda L. Now 0 to take it n pi, sin n pi is nothing but 0, then sin lambda L, n pi equal to lambda L to find the value of lambda. Lambda equal to n pi by L. So same procedure to follow with initial 0 velocity, non-zero velocity. So first using condition 1 a0, using condition 2 lambda n pi by L. Now you take this is the equation. This equation substitute in the previous equation, previous third equation. To substitute fourth equation into third. Substitute fourth equation in the previous equation, third equation. Therefore y of x comma t equal to b sin n pi x by L. Lambda value I'm going to substitute. Then c cos n pi at by L d sin n pi at by L. Now consider this is the equation number 5. Next, using condition 3 in 5. What is the condition 3? T equal to 0. So y of x comma 0 b sin n pi x by L c cos 0 d sin 0. So cos 0 1, sin 0 0. The left hand side value no displacement. So initial 0 b sin n pi x by L into c. So these are the non-zero. Take it left hand side. C equal to 0. Now I consider this is equation number 6. Substitute this 6 equation into the previous, substitute equation 6 in the previous equation 5. Therefore y of x comma t equal to b sin n pi x by L, then c0 d sin n pi at by L. Now this equation I'm taking b and d to combine with the constant n from 1 to infinity bn sin n pi x by L sin n pi at by L. So y of x comma t. Now you consider this is the 7th equation. Next, using 4th equation in 7th. What is the 4th? Differentiate 7th equation partially with respect to t. Therefore when I am differentiating partially with respect to t, though y of x comma t by though t, n from 1 to infinity bn sin n pi x by L, because of these are the constant. So only the t term for sin n pi at by L. When I differentiate with respect to t, cos n pi at by L, then into n pi a by L. Now put t equal to 0. So when I substitute t equal to 0 for this equation, though by though t equal to n from 1 to infinity bn sin n pi x by L cos 0 n pi x by L. For the left hand side value, initial non-zero velocity, therefore this is a v naught sin cube pi x by L equal to n from 1 to infinity bn n pi x by L into sin n pi x by L. Now generally after that we are applying half range sine series, but whenever I'm looking the problem is a trigonometry formation, therefore any possible, what is the possibilities? We know earlier the formula without the finding the half range series, very simple. So sin cube x equal to 3 sin x minus sin 3x by 4. So this formula to apply with this form, therefore v naught sin cube, so 3 sin, what is x, pi x by L minus sin 3 pi x by L whole divided by 4 equal to expand this n1, so b1 pi x by L sin pi x by L, then plus b2 2 pi x by L, then sin 2 pi x by L, then plus b3 3 pi x by L sin 3 pi x by L, and so on. For this term, just multiply with the constant, so 3 v naught by 4 sin pi x by L and minus v naught by 4 sin 3 pi x by L equal to b1 pi x by L, then this is a pi x by L is fine, pi x by L, or sorry, this is a, when I am differentiating only pi n pi by L, so this constant not x, n pi by L, so this is a pi by L, this is a 2 pi by L, 3 pi by L, therefore this is a term b1 pi by L sin pi x by L plus b2 2 pi by L sin 2 pi x by L, then plus b3 3 pi by L sin 3 pi x by L, then b4 4 pi by L sin 4 pi x by L, and so on. Now compare to this sin pi x by L. So when I'm looking here, see this term sin pi xl, sin pi xl, sin 3 pi xl, sin 3 pi xl. So compared to this, we have the value b1 equal to, sorry, b1 pi by L equal to 3 v naught by 4. From this to calculate b1 value, 3 v naught into L divided by 4 pi, then b2 0, when I compare left and right hand side, b2 0, b3 the coefficient of sin 3, the coefficient of sin 3 pi x by L, so b3 3 pi by L equal to minus v naught by 4, and from this b3 minus v naught L by 12 pi, then b4 0, and so on. To substitute this value, what is the value? Now I substitute, this is a 8th equation. So substitute 8th equation in 7. So what is the 7th equation? Y of x comma t, n from 1 to infinity, bn sin n pi x by L, then sin n pi at by L. When I expand n 1, 2, 3 and so on, therefore b1 sin pi x by L sin pi at by L plus b2 sin 2 pi x by L sin 2 pi at by L plus b3 sin 3 pi x by L into sin 3 pi at by L plus b4 sin 4 pi x by L then sin 4 pi at by L and so on. So now you substitute 8th equation in 7th. Now what is the b1 value? b1 is nothing but b2 b4 0, b1 is 3v naught L by 4 pi, 3v naught 3v naught L by 4 3v naught L by 4 pi. So therefore 4 pi sin pi x by L then sin pi at by L. The other term 0, b2 0 then plus b3. b3 is nothing but minus v naught L by 12 pi into sin 3 pi x by L sin 3 pi at by L and then b4 b5 b6 and so on, right? So b4 0 and so on. Now finally the equation is nothing but y of x comma t equal to 3v naught L by 4 pi sin pi x by L sin pi at by L minus v naught L by 12 pi sin 3 pi x by L sin 3 pi at by L. Now this is your final solution. If any common possibility to take out, take it here, the common LCM whatever, otherwise you just stop up to this. So this is your final solution, y of x comma t. So thank you everyone.